sequence. Okay, and one more question that is asked in group. Okay, so I have made the video previously, but there is some problem in network, so after I cannot upload the video. Okay, so something written and something not written. Okay, so data written, I am not going to write that. Okay, but data not written, this is something, I think the last question, this question is not written. Okay, so I will write after that. Okay, just I'm saying so that you can understand. Okay, so say this question, f from close 0 to r, function f is equal to x to a sin 1 by x square when x non 0 and 0 when x equal to 0. Okay, so this function is first function is f is continuous for any x star a greater 0. Okay, so see first option. See here, option for option is given. F is equal to x to alpha sin 1 by x square x non 0 when 0 x equal to 0. Okay, so see when x non-zero, x is a real number, so x can be 0 or non-zero. When x is non-zero, then sin 1 by x is continuous. Okay, it's zero function, so it's continuous. And x is alpha alpha is 0, and it is a polynomial, it is also continuous. So product of two continuous functions again continuous, na? So x non-zero and a greater 0, then it will be continuous. Okay, so you have to check only for x equal to 0. So you have to check the continuity of x at x equal to 0. So continuity, how you check the continuity of 0? If you can prove limit x to 0 f will be equal to f0, then this will be proof that f will be continuous at 0. Okay, so I am finding limit x to 0 fx. So limit x to 0 fx will be x to alpha sin 1 by square. Okay, now it is a bounded quantity, this is bounded by 1. Okay, and this is the polynomial since alpha greater 0. Okay, alpha greater 0, alpha is a, this is a, so f2, this will be a. So this is a is equal to 0, so this is the polynomial. So this limit tends to 0, x tends to 0, and this bounded quantity, so overall limit will be 0, na? So 0 and 0 will be nothing but f0. So limit x tends to 0, f will be f0, so f will be continuous at 0. So okay, option 1 will be correct in this way. Now if you find the differentiability, is saying f is not differentiable at x equal to 0. So you have to find the f dash 0. So f dash 0 will be nothing but option 2. Limit x tends to 0, fx minus f0 x minus 0. So f0 will be 0, so you have to put 0. Now fx will be x to a sin 1 upon x square x. So this gives limit x to 0, a for a minus 1 and sin upon x square. Now this is again a bounded quantity, and this tends to 0 when this part is 0, this part greater 0. Okay, if a minus 1 will get a 0, then this is a polynomial, na? So this tends to 0, and this is a bounded quantity, so overall limit in this case will be tends to 0. So a will be greater than 1. So if a greater than 1, then the f is differentiable and f dash 0 is 0. Okay, so if a not greater than 1, then it will be not differentiable. So a not 1 means a less equal to 1. So you can say a less equal to 1, and a greater 0 from continuity. So 0 less than a less equal to 1, then f is not differentiable. Okay, so you can say option B is correct. F is not differentiable, and if 0 less than a less than 1. Now for C and D, there is a result. This type of function x to alpha sin 1 by square and x to beta is bounded variation. Okay, so this is the result. If f is equal to x to alpha sin 1 by x to beta is x non-zero, 0 when x equal to 0. This is bounded variation. If bounded variation, if you can leave alpha greater than beta. So in this question, say alpha equal to a and beta equal to 2. So alpha, so this function will bounded variation. The given function will bounded variation if a will be greater than 2, na? So D, in the question D option will be correct. Okay, but C will be correct because it's saying a greater than 1, so it is not correct. Okay, so correct option will be A, B, D. Okay, so correct option will be A, B, D. Okay, I hope you understand. Okay, so if you have no doubt, you can ask. We will go to the next question. So this is the question from part B, and asked in June 2017. Okay, so the question is sequence given n. Okay, so n, I am writing that n equal to 1 plus minus n, 1 upon equal to n greater than 1. So when n is even, then this part will be 1, na? So 1 plus 1 equal to n. When n is odd, then 1 minus 1 equal to n minus 1 gives. Okay, so you can write this 1 plus 1 minus 1 whole to minus n whole to minus 1. Now if you take a limit, we all know this part, limit 1 plus 1 by n whole to n, this limit will be e. Okay, so this goes to e, and limit 1 plus 1 minus, this limit will be again e. So it is a minus, so limit will be e inverse. This limit is equals to e, this limit will be inverse. So limit tends to n will be e when n is odd, and n inverse when n is even. Okay, so limit, so basically this sequence a n has two subsequence. One is a to n and other is a to n minus. And a to n, this sequence a to n tends to even sequence, even guess it tends to e inverse. In odd sequence, when the sequence is odd term, even sequence tends to e inverse, and odd term tends to e. Okay, so limit supreme will be what, e, and limit inferior will be 1 by e. Okay, so limit supreme will be e and limit inferior will be 1 by e. So so this will be position is correct, and this is not correct. This is because 1. This thing is 1. No, 1 is on the on way. Not correct. This is not correct. So the 4 option will be correct. Okay. Now going to this question. This question also asked in June 2017. Okay. Also asked in June 2017. So see this question. It's saying that lambda n is 0 to 1 integral to t on plus 1 for an integral number. Okay, n integral number means n greater than 1, obviously. So if n equal to 1, then what will happen? N equal to 1, this is a sequence. If n equal to 1, what happen? On 0 to 1 dt 1 plus t. So this will be ln 1 plus t. If you integrate this, put t, then put limit na 1 plus to be ln 2, and if you put t equal to 0, this is ln2. Okay, so lambda will be ln2. So lambda will be ln2. You will know ln2 value 0.693 something. Okay, now if n greater than 1, when n equal to 1, then this n equal to, then lambda n gives lambda n. When equal to 1 gives ln2. Now when n greater than 1, because initial number, so n can be greater than 1 also. So when greater than 1, we have to find what will be n. When n greater than 1, see n greater than 1, this will be like this: 0 to 1 into t 1 plus 2n. So 0 to 1, 1 plus 2 to minus n. Now if we integrate this, this gives 1 plus t whole power minus 1 plus 1 minus 1 plus 1, 0 to 1. Okay, so you will get 1 upon 1 minus n, 1 upon 2 power n minus 1, this 1. If you put d 0, then this is 1 na. So you can write this like this. So you can say lambda n equal to 1 upon n minus 1, 1 minus 2 power n minus 1. Okay, when n greater than 1, n greater than 1, you can say. And when this will be ln2 if n equal to 1. Okay, so this is the sequence lambda n. I bet. Okay, so now it says that lambda n, first option it says the lambda n does not exist for some n. No, lambda n exists for every n. Na, for lambda n equal to 1, you will get lambda 1, and for n equal to n, for any n greater than 1, I have find. For any n greater than 1, this will define. Na, for any n greater than 1, you can say n minus 1 will be greater than 0. So this part will define. This part also define. Okay, so you can get lambda n. So option 1 is incorrect. Okay, lambda n exists for every n. So option 1 incorrect. Option 2, lambda is for every n and this is unbounded. Okay, so you have to check the boundedness now. So you have to find limit n from here, find limit n to infinity lambda n. What will be this lambda n? Okay, see if you take n to infinity, means if you take this case, because here n greater than 1 for last case. So this part 1 by this tends to n to infinity, this was 0. In this part 1 this tends to infinity, 1 over 2 by infinity, this tends to total tends to infinity, 1 over infinity is 0. So 1 minus 0 means this tends to 1. So this part tends to 0, and this part tends to 0, and this part tends to 1. So what will be the product limit? 0 and 1. So this is 0. Okay, so lambda, so limit n to infinity lambda will be 0, right? So if I say limit n to infinity, your lambda will be 0. So means lambda n is a convergence sequence. You can say lambda n sequence is a convergence sequence. If all every convergence is bounded, na, there's a result. Lambda n every convergence sequence is bounded. So lambda will be bounded. No issue. Okay, because every convergence sequence is bounded. So lambda n is bounded. But B option saying it is unbounded, na. So how it is true? It is incorrect. It is unbounded. So lambda n is for every n and is bounded. So it is true. So the option 3 will be correct. Now we have to verify this. Lambda into lambda n power 1 by n will be 1. To verify this, we know a result. Okay, I'm writing the result. What the result? Option 4. You all know. If lambda, suppose we know the result. I'm writing the result that we know. If xn be a sequence of positive term, okay, and natural number, let xn be a sequence of positive term, okay, and let xn be a sequence of positive term, then this result will happen. This will be hold. Limit n to infinity, xn to the 1 by n will be equal to limit n to infinity xn plus 1 upon xn. We apply this result. See here, each xn is greater 0, each lambda is greater 0, because ln2 its value is 0.693. okay, so see this is greater 0, and this is also greater 0, this is also greater 0. okay, so you can say lambda n is greater 0, so you can apply the result here. okay, I have written the result I have written now, you can apply there, because if lambda n is greater 0 for any n greater 0. okay, so first observation that lambda n is greater 0, okay, for any n natural number. So you can apply the result, this result. You have to find this. You have to find limit n to infinity lambda n power 1 by n. So find this so that you can get the value of this. So I am finding this. limit n tends to infinity lambda n plus 1 upon lambda. What will be this? This will be nothing but limit n tends to infinity. What is lambda n? Lambda is nothing but this 1 upon n minus 1 1 minus 2 to power n minus 1. Okay, for n greater than 1, n for n equal to 1, this is n 2. So now you take the n greater than 1 case. Take the large case now, because you are evaluating the limit s n tends to infinity, means you have to take the large n. So you have to take this case. So find 1 upon n plus 1 gives n. This is 1 upon 1 for 2 power n. Now this gives 1 upon n minus 1, 1 upon 2 power n minus 1. Okay, so if you simplify it, so you will get limit n tends to infinity 1 minus 1 by n. Okay, 1 minus this gives 2 to power n. This will become 1 minus 2 by n minus 1. Okay, now this limit n tends to infinity tends to 0, so this limit tends to 0, this limit also tends to 0. Okay, so this gives 1 minus 0, this upper part tends to 1 minus 0, means 1, lower part tends to 1 minus 0, means 1, and this limit tends to 0, so this limit tends to 1. So overall limit will be how? What will be overall limit? This tends to 1, so this is 1, upper part is to 1, lower part is to 1, so overall limit will be 1 na? So overall limit 1. So limit tends to lambda n plus 1 by lambda n, you get 1. So from there you can say you get limit intensity lambda n plus 1 upon lambda n. This is 1, and according to real you can say this is nothing but, you can say from here the lambda n power 1 by n will be 1, because this value and this will equal na, both are equal. So if it is 1, then it is again 1, and this is all, and this will be required. Okay, so limit is lambda n power 1 by n will be 1. So is 1 given, so it's correct. Okay, so hope you understand. So in this question class cards will be option and 3 and 4. Okay, if you any doubt you can always ask in the comment section. Okay, and there is also our WhatsApp group. Okay, you can ask any question, any query, any doubt here. Okay, and if you any doubt, you tell me in the WhatsApp group. It is not, if it not resolved anyhow, then I will make that video. Okay, that made that question in my video. Okay, okay, like this question I have taken. Okay, this is an important question, so I have taken that. Okay, in my video. And also I have solved 2 questions, on question part B and question part is part C question. This is part C question. Okay, and this is part B question. Okay, 3 more question. June 2017 this question asks. Okay, in the next video we'll discuss one more also 2 or 3 more question of from sequence. Okay, and follow my channel. Okay, keep watching, and also please join me in my WhatsApp group, okay, and take the benefit. Okay, so without delay I am closing this session here. Okay, so thank you. If you have any doubt you can always ask me in the comment section. Okay, and okay, so thank you.